Welcome back to another exciting day in mathematics. Whoop, whoop. Warm up 11's on the screen. Let's get started, please. Shouldn't take you long. Copy and go. All right, check with your neighbors, see what they got. It should be done by now. All right. So, by now we should be experts at this since we've been doing these since last week. So get us started with number one. Let's see. How about Lorenzo? Give us the inequalities that you wrote. First, give me the red one. Negative what? Negative 6. 1, 2, 3, 4. Negative 5. Okay. And then the rest of it is x. What is negative 5 compared to the rest? Less than and equal to. All right. Pass someone. Jaime, can you give us a green one? Negative 2. And all the other is x. So what are the others compared to negative 2? Less than, and no equal to, because it's an open point. Hands, have you got that by yourself? All right. And of course, solution set of x such that, and you close your bracket. All right, check with the neighbor for the inverse of this one. And I'm just going to want the answer. I don't want you to show me the word. Get the answer, show your neighbor what you got. Then we're going to have, how about, what haven't we called on in a while, Julian? Who haven't we called on in a while? Autumn, okay. So check with the neighbor, see what you got for the inverse of number 2, and then Autumn's going to enlighten us with the answer for that one. Answer for number 2. Are you ready? Okay. What'd you get, Autumn? Equals to? F of x, but with a little negative 1. Hands, have you got that? That is correct. Double check your work. Ooh. Autumn in the house. Next, we need f of negative 1, an answer, f of 0, an answer, and f of 1. Check with your neighbor, and Autumn's going to pass it to someone. Check with the neighbor what you got for those 3. All right, pass someone, Autumn. Who? Julian, f of negative 1. 11, f of 0. 6, f of 1. 1. Hands, have you got that? That is correct. Double check your work, please. All right. Copy the agenda. Warm up number 11 done. Intro to functions. Today we're moving on. And I'm going to leave you some practice or a play sheet, numbers 1 through 11. Copy that. And also, one thing that I forgot that I haven't done here, because yesterday we were having some technical issues, is that every first of the month or first day of the month, we get new seating arrangements. Oh, yes. So as soon as you copy the agenda, get your stuff, get out the way, please. Let's go. go. Yes, Mr. Q. All right. So warm-up 11 is done. Intro to functions. Today we're moving on. And tonight's home plate, place your Q, numbers 1 through 11 only. All right. So here's the code to access the home plate tonight. HVC8L. Copy that. HVC8L. HVC8L. Last night's home plate was this play sheet, 3.6C. So go to Canvas, turn that in, please. I want to see what you practiced. And that was enough practice of inequalities. Today we're continuing to functions, domains, and ranges, because we need to get going with all our transformations pretty soon. So there you go. And make sure you're keeping up with your assignments, because I'm sending you a progress report home this week. Just giving you a heads up, okay? I don't wait for the district to send anything home. I'm the one that sends it home. How about them apples? Oh, yeah, you guys are playing checkers. I got chess going on over here. Let's go. Let's go. Once again, tonight's home plate, place your Q, is going to look something like this. In case your code doesn't work, you already know that you can go to the YouTube channel. Yeah. All right. And you're going to need a Cornell note. You don't need the FAIR model for functions, since we already took notes on that. And before anything else, your attention really quick, you need to come back here to get a graphing paper, a pink paper, and a highlighter. Do that, please, right now. Go. All right. So, once again, the way we're going to communicate and turn in assignments is always on Canvas. That's why I said, okay, guys, go to Canvas really quick, go to the modules, and look for your assignment and turn it in. If you are behind on some assignments, remember, you can always go to YouTube, go to see the lesson prior, and it should be in there. Now, if you really don't find it, come see me. I can give you a code. I need to look for the code so I can give you the code to access. However, late assignments, how much you think are worth? Tell your neighbor, how much do you think late assignments are worth? Yeah, you get the special of the day, half off. All right? So with that said, y'all ready? Here we go. I can identify functions. I can identify functions. By now, like I said, we already did the introduction of functions. You already have the notes. We don't need a FAIR model. And we talked about some vocabulary, ordered pairs, X and Y. So whenever I give you an ordered pair such as 2 and 3, we already know that 2 is X, Y is 3. When I give you a bunch of ordered pairs together, they're called a relation. And they look like this. Don't copy that. You already have that. From there, if I ask you for the domain of this relation, remind your neighbor what domain stands for. It stands for all the what? X values. So the domain for this one would be 2, 0, 100, -5, -2. But how do we write it in a set? We write the set, and we start from the least to the greatest value. From there, from that same relation, I can ask you for the range. And what is the range? All Y values. So that means if I gave you this, you're thinking 3, 0, 3, 7, -3. In a set, once again, you write set, and you start from least to greatest without repetition. You guys remember this? Yes? All right. So, with that said, function. We said that a function is a relation, exactly one output value for each input value. You already have these notes. Look at the example. Look at the non-example. We went over this, and I said, if you have a function, each value is assigned a number. So look at this -2, it's assigned the 3. Is that correct? And then we got -1, it's 4. 0 is 5, 1 is 6. And if negative 2 comes up again, it should be what? 3 for its y value. Therefore, turn to your neighbor, let them know why this one right here is not a function. Why is that one not a function? All right. Looks like Eileen's got it. Very good, Eileen. I see you. Lorenzo's got it. Very good. Let's go with Carlos. Why is this one not a function? Right, so for negative 2, it should have been a 3 if it repeated, and here it was a 7. That is correct. That's why this one is not a function. And how do functions look like, Mr. Q? Well, they are y equals to something x, or it's a two-variable equation, yes. However, we're transitioning now from y form to what? To f of x form, because now we're going into function notation. I give you guys non-examples, and then I give you guys more non-examples, and we wrote some hashtags for that. All right, we already have those. Vocabulary, we talked about interval. It's a part of a line without any breaks. That means a chunk of a line. We talked about finite interval. That's when the 2 points have n, and we use brackets for that. Infinite interval is when we have on the sides with no ends, or we have infinity, or it's an open end, and we use parentheses for that. So just to clarify this, because last time I sensed a little bit disturbance in the force, you have this table, get that pink paper in front of you, and you need your colored pens if you have them. Copy these graphs, please, in there, and we're going to go through each of those together. Yes, copy that, please. I'll give you some time. All right, here we go. For the sake of time, y'all ready? Start with the first one. Look up, please. For the first one under each graph, we're going to write an inequality notation. By now, we should already know how to do that. So I'm going to zoom in to the very first graph. There it is. So, here we go. We always start with our what? Our dividing point. What is our dividing point for this one? Negative 3. So we write negative 3, which is this dividing point. Next, where's the shading? It's to the right. So all this corresponds to a variable, and we usually use what? X. So therefore, negative 3 compared to all these numbers, what is it? Negative 3 is what to all these numbers? Less than, and check, is it an open point? Yes, so we don't put an equal sign. It stays like that. This is called what? Inequality notation. Do you see it? Yes, there it is. Next, do we know how to make this into set notation? Yeah, tell your neighbor what to write for set notation, including that. What would you write for set notation? Yeah, we've been doing it already for almost 2-3 days. Solution set of x such that, then we write our inequality, negative 3 less than x, and then you close your set notation. How are we doing? Pretty good? All right. Let's do the second one together. Here we go. I'm going to give you a head start for this one. Write your inequality and write your set notation. All right, let's see what you got. Start with the dividing point. What's my dividing point? It's right here, which is 4. The shading is to the left, so we write over here x. Question, what are all these numbers to the left compared to 4? Less than. Is this an open or closed point? Close, so we put an equal sign. So far so good, yes? And then we just translate that into a set notation. Solution set of x such that x less than or equal to 4, and you close your solution set. All right. Not bad, yes? So that extra practice with the solution set helped. Very good. Okay. Let's go to the next one. Here it goes. Let me move up. Let's start with our dividing points. Here we go. What is my dividing point on this one? -2. How about this one? 5. But now notice that we have the shading in between those two, so that means all that corresponds to what? X. So whenever you have this kind of graph, this is known as an and, label that, we always do arrows to the left. That means -2 less than x less than 5. Then we check, is this an open point? Yes. How about this one? Yes, so it stays like that. So, how do we write this in set notation? I'll give you a head start. Go. Write your set notation for that. All right, show your neighbor, see what you wrote, see if they have the same thing as you. Yes, so we write solution set of x such that -2 less than x less than 5, and you close your solution set. So, we did one together. Do the last one by yourself, that next one. Write your inequality notation, and then write your set notation. I'll give you a head start. All right, here it goes. Start with our dividing point. What's our dividing point here? It's -5. How about over here? -1. The shading is in between, so we write what? X. Arrows to the left. However, which one has a closed point? -5, so we put an equal sign. How about this one? No, that one's an open point, so we leave it without the equal sign. Therefore, set notation, solution set of x such that -5 less than or equal to x less than -1. Hands if you got that by yourself. Yeah, we got it, right? All right. So, with that said, shall we add one more? What do you guys think? Now, let's finish these really quick, and then we'll do one more at the end. All right, let's go back to the beginning. Let me zoom out. All right, so we got what kind of notation? Inequality. We got set notation. Here's our next one, interval notation. For interval notation, I want you to make a note on the side, over here on the side. If you have space, put an asterisk, a heart so you won't forget, aww, and write, use those are known as brackets, use brackets only when, my goodness, only when it's a closed point, comma, anything else, use parentheses. All right? So here we go. So we're going to use brackets when it's a closed point, and anything else, doesn't matter what it is, we use a parentheses. So let me zoom in. We're going to do the first one for interval notation. Here we go. Bless you. So for interval notation, always start with your dividing point. This one is -3, comma. And then check and see if there's another dividing point. Is there another dividing point after -3? No, Mr. Q. There's an arrow. So what does the arrow indicate? That it keeps going to the right, which is to positive infinity. So I want you to write positive infinity. So read the note to yourself. What does the note say? Read it. It says, use brackets when it's a close point. Anything else, use what? So look at it. Look at the graph. Do you see a close point here? No, so we're going to use a parenthesis. Is this a close point? No, it's an arrow, Mr. Q. Then it's a parenthesis. All right, let's go to the next one. This one. What is our dividing point? Dividing point is 4, but now it's on the right. On the right. The other way, it's a what? An arrow. So what do we write? It's going all the way to the left to what? Negative infinity. So we're going to write negative infinity. So now tell your neighbor, what are we going to write here? Parentheses or brackets? Which one is which? Talk it over to your neighbor. What do we write there? All right. I think Autumn's got it. Very good, Autumn. See you. Scarlett's got it. Very good, Scarlett. All right, so let's go with Lorenzo. What would you write for infinity? Parentheses. All right. How about for number 4? What would you write for number 4? Bracket. That is correct because it's a what? A close point. Let's go to the next one. Start with the dividing points. What's my first dividing point? -2, comma. Do we have another dividing point? Yes. 5. Turn to your neighbor, let them know if we're going to do parentheses or brackets and why. Pass someone, Lorenzo. Carlos? Both are going to be parentheses. That is correct. All right. Do the last one by yourself. The interval notation. Last one, do it by yourself. All right. Show your neighbor, see what they got. All right, Carlos, pass someone. Jaime. So what are our dividing points? All right, and what do we use? Hands, have you got that? That is correct. So what can we conclude from that notation? Interval notation. We conclude, Mr. Q, that anytime that there's a solid point, a close point, we use a bracket. Anything else is what? Parentheses. All right. Let's write the words. Let's describe this. Write it in here. All real numbers greater than -3. So let's see. All real numbers, they keep going, greater than -3. Okay. Let's look at this one. All real numbers, what? What would we write there? Less than 4. Less than 4. Comma, what? Over here, all real numbers greater than negative 3. Why? Because it's an open point and it doesn't include negative 3. Here, all real numbers less than 4, comma, what? Including 4. Including 4. And it's because of this bracket. Go to the next one. All real numbers between what? Negative 2 and 5. Write the last one by yourself. See if you get that by yourself. What would you write for the last one? All right. Check with the neighbor. What did they write? I might pass someone. Leo, what do you write? All real numbers between negative 5 and negative 1, comma. What else did you say? Including negative 5. That is correct. All right. How we doing? Good? All right. Type of interval, we'll talk about that later. I do want us to get to the next section. So before I move forward, send you a picture of your notes. Let me send you the screen. Thank you very much. So continuing with functions, before we get into transformations, I'm going to try and clarify domain and range. It's going to go pretty fast, so stay focused. Get the graph paper in front of you and your highlighter. So here we go. Look up to the screen. Who's seen this game before? You guys seen that before? Yeah? Back in my days, they used to have a machine in the 7-Eleven, and man, I spent hours on that. But anyways, it comes to a point, guys, where there's a ship that drops from the top and it's trying to get rid of this ship down here, and it drops like this. However, it sends a radar to try and block it like so. However, the game also keeps increasing the range of the blast of our white ship. And it looks like this. Look up. Let's say I have the ship right here. And here's my beam. Highlight that section on your graph paper, please. You can use the small size. On one of them, highlight that section. Show your neighbor between what and what you highlighted. All right? So if you were to give me directions or give your neighbor directions between what and what did you highlight? Tell your neighbor. Between what and what? All right? Go with Julian. Between what and what did you highlight, Julian? 7 and 8? 0 and 8? Oh, 2 and 8. Oh, my bad, my bad. 2 and 8. Check in your graph. Did you highlight between 2 and 8? Now, check this out. Since we are talking about x, this is what we call the domain. The domain is going to be between 2 and 8. So since it covers everything in between, what do you think we're going to label everything in between? X, that is correct. Arrows to the left. Since it includes the 2 and the 8, we put equal signs. And this is what kind of notation? Inequality. Can you make this into set notation? Do that into set notation, please. Set notation is what? Solution set of x such that -2 less than or equal to x less than or equal to 8. And our third notation, can we write that in interval notation? Yeah, what are my dividing points? 2, 8. Since the 2 and the 8 are included, what do we use, people? Bracket and bracket. All right. As you're putting away your stuff, let me show you a couple more. Look up. Look at this one. Tell your neighbor between what and what is our domain? Yeah, -3 and 3. How about this one? If I have 2 more ships, between what and what? -9 and 4. Hold on. Before we go, look at this one now. Between what and what, starting from the bottom? 1 and 9, and this is what we know as the range. Have a good one, guys. Enjoy your home plate. Put away my highlighters on the back, please, on your way out. See you guys next time. Peace.